Assalamu alaikum. I am your presenter Rafia Said, and we will discuss about atomic absorption spectrophotometry in this video. Atomic absorption spectrophotometry is an analytical technique which is used to determine the concentration of metal atoms, ions, or metalloids in a sample of interest. This technique measures the amount of light absorbed by the atom of their characteristic wavelength. The modern form of this technique was largely developed during 1950s by Alan Walsh and a team of Australian chemists working at Commonwealth Science and Industry Research Organisation, Division of Chemical Physics in Melbourne, Australia. Its working principle is based on interaction of atoms with light at specific wavelength. When atoms in a gaseous state absorb light at their specific wavelengths, they undergo electronic transitions from lower energy state to higher energy state. This absorption of light is directly proportional to the concentration of element being analyzed in a sample. Instrumentation. So, following are the components of atomic absorption spectrophotometer: sample holder, atomizer, hollow cathode lamp, monochromator, detector, and processor, and calibration. These all following components you can see in this diagram. The process starts by introducing the sample. Depending upon the atomizer, sample can be liquid, solid, or gaseous state. To introduce the sample in the system, following phase can be considered: first, nebulizer, and second, autosampler. Then we have atomizer. Using an atomizer, the sample is converted into atomic vapors for analysis. There are two types of atomizer: first, flame atomizer, and then graphite atomizer. The most common type is flame atomizer. It use flames to convert sample into atomic vapors, and then graphite atomizer. For more sensitive analysis of trace element, a graphite furnace is used. The sample is placed on a graphite tube and the temperature is increased to vaporize the sample. Then hollow cathode lamp is used. The HCl serve as the light source in this spectrophotometry, and each element requires a separate hollow cathode lamp. It contains the element of interest as a cathode and is filled with an inert gas at low pressure. When a high voltage is applied, the inert gas ionizes and the resulting ions accelerate towards the cathode, causing the emission of light at specific wavelengths characteristic of the element. After the sample has been atomized, the emitted or absorbed light from the HCl is dispersed into its component wavelengths using a monochromator. It separates the characteristic wavelength of the element from the other unwanted wavelengths and ensure accurate measurements. Then we have detector and processor. The detector in atomic absorption spectrophotometry is typically a photomultiplied tube. The PMT measures the intensity of transmitted and absorbed light from the atomized sample. When the light is absorbed by the atoms in the vapor, the result in reduced light intensity reaching the detector. The PMT converts this light intensity into an electrical signal. The electrical signal from the PMT is sent to a signal processor, which amplifies and processes the signal to make it suitable for analysis. Before analyzing unknown samples, a calibration curve is constructed using a series of standard solutions with known concentrations of the solution being analyzed. The calibration curve relates the signal intensity to the concentration of element. By comparing the signal from the unknown sample to the calibration curve, the concentration of the element in the original sample can be determined accurately. Let's discuss the advantages. It is low cost per analysis. It is easy to operate. It has high sensitivity and accuracy specificity. It is mostly free from inter-element interference, and it has wide application across many industries. Applications of atomic absorption chromatography. It is used in pharmaceutical industries to quantify metal impurities in drugs and medicines. It is widely used to determine the concentration of trace elements in water, soil, and air sample. It is also used in clinical diagnostics to measure essential traces element in biological sample like blood and urine. There are some limitations of atomic absorption from spectrophotometry. Okay, so it cannot detect nonmetals. Its equipment is expensive. It can measure one element at a time, and it is more appropriate for liquids than solid.